Hello everyone. Today I will solve the question 113 path sum 2. And the question is, they will give us a binary tree and an integer target value, and we need to return the path uh, where the sum of the values of that path is the target value. So like in this example, they will give us a binary tree like here, and they will give us a target value that is 22, and we need to return the path where the sum of the values of that path is 22, like this: 5 4 11 2, 5 plus 4 9 plus 11 20 plus 2 22, and here 5 8 4 5, 5 8 13 plus 4 17 plus 5 22. So we will return here as an output the path 5 4 11 2 and the 5 8 4 5. So it is our question, and in the second example the target value is 5, right? The target value is 5. So 1 1 2 3, the maximum value we can get is 4, 1 plus 3. So we can't return any output, so we will return the vacant array or empty array, you can say. So now our logic will be, now I am explaining you our logic to solve this question through this example. Like in this example, the target is 22, right? Our target is 22, and we have this binary tree. So it is our function DFS. Through DFS we will go on each node and we will check these statements and we will implement like this. First we will check if that node is leaf node or not, else we will call the left child and right child. After that we will first check whether it is leaf node or not, leaf node or not. After, if it is not, we will call the else part, that is we will call left child and then right child, and after that we will backtrack and we will pop it. So at the initial position the target will be 22, and we will also change the target value after each function call. First the target will be 22, we will start from 5, and target is 22 here, right? Now if we will check whether it is leaf node or not. It is not leaf node because the left child and left node and right node is not null, so we will go on else part. It is our else part, so we will call left child. So we will call left child. Now we will give 4 as a node. So here in this function we are 2a at 2 8 because we have called the left child. Now 4 is our node, right? Now we will check for 4 whether it is leaf node or not. It is not, so we will do again the else condition, that is left child call. We will call the left child, that is 11. Now our 11 will be the leaf node, but here you will notice that we need to decrease the target also, because when at the initial time the target was 22, right? But for this node 4, target would be 22 minus 5, because we have already counted 5. You can do one thing, you can store these values, like when we will call the first function 5, we will store 5. Now we will store 4 here, and after calling the left child of this 4, we will store 11. and we will decrease the target as 22 minus 5, that is 17. 17 minus 11, 22 minus 5, that is 17. 17 minus 4, that is 13. Now here target is 13. Now we will call the again, we'll check whether it is leaf node or not. It is not, so we'll call the left child. Now 7 will be our root, so we will put 7 in our path, and we will check whether it is leaf node or not. Yes, it is leaf node because its left child and right child has null value, right? So what we will do, we will check whether the target is 0 or not. Now our target will be 13 minus 7, it will be 6. So target here is our 6. Now we will check whether it is 0 or not. It is not 0, it is not 0, so we will simply return, and we will backtrack, we will pop it. So we will pop it, we will remove this 7 from our path, and we will go back to the our previous function, because we have completed the calls of this function, right? We have completed if condition, we have backtrack, we have already on this function call, the 11. Now we have called left child call, we have already called. Now we will call for the right child call for this place. Now we will put 2 here in our path, and the target was 13 for this function call. Now target will be 13 minus 11, 2. And after function call of 2, when we will come on 2, we will check whether it is leaf node or not, and the target will be now 2 minus 2 is 0, right? 2 minus 2 is 0. Now we will check whether target is 0 or not. Yes, it is 0, so we will put this path in our return, we will in our answer. So we will add 5, 4, 11, 2 in our answer. Now we will go back again, we will backtrack this 2, and we will call the right child of 4, which is null. So we will check if it will be null, we will simply return. Now we will go back again on 5, and we will call the right child. So our node base node will be 2, and target will be 22 minus 5, that is 17 here. So here again target will be 17, and we will call its left child again, and we will decrease the target, but we will not get the answer, you will check. So again we will get answer for 5845, like as I have already explained you, 5845. Lastly we will get the answer. So what we are doing, we are storing the path value, and we are decreasing the target on every iteration. On whenever we are changing the root value, we are decreasing the target, and we are going to the till to the leaf node, and we are finding whether it is our right solution or not. If it is right solution, if target is 0, then we store it in our answer. So now I am showing you our solution. So as I have already told you, it is our answer, where we will store the answer. Now it is our main function. It is our path where we store temporary the path. We will call this function for DFS to traverse on each node, and we will return the answer. Here in this function, our first is root node, which is our base node. This is target, new target, and this is the path where we temporarily store the values. It is the condition when we return, when we get uh, root as a uh, root as a null. If it is not null, we simply push back the values of that root to our path, and we decrease the new target, and we check here for whether it is leaf node or not. If it is leaf node, we check whether the new target is 0 or not. If it is not 0, we simply come here to pop back. For the backtracking, we simply backtrack and we go to the previous function. If it is not leaf node, we simply call left child and right child. If there is no right child, we will come here, the root will be null, so we will simply return. Now we will see our code. So it's running. Thank you.